twice as a commander. My colleagues have put together an interesting little experience for you today. You're about to go on a high-fidelity launch simulation, and I'm going to help you get through it. See, before any launch, all astronauts have spent thousands of hours being tested and trained in simulators, a lot like the one you're going to ride. You'll be riding in a special module that fits right into the payload bay. But before you go aboard, we'd better go over a few basics. Launch preparations for your mission would have started accelerating here at KSC months in advance. Let's cut through all that and move you way closer to launch. I'll start your clock at, say, 4 hours before liftoff, when it's still dark out. Before you got suited up, the shuttle's external tanker ET was fueled up. The ET holds fuel for the shuttle's 3 main engines. Inside the ET, there are actually 2 separate tanks. One has liquid hydrogen at 423 degrees below zero. The other, liquid oxygen at 298 degrees below zero. They start really cold. But when those 2 liquids meet in the shuttle engines, you'll find out. About 2 hours before you launch, you boarded the orbiter through what we call the white room. As you climbed through the hatch, that orbiter already seemed like it was a living, breathing thing. Then they pulled back the access arm and left. Everybody else is smart enough to get out of the air that fails, and you and your crewmates are strapped to the reason why. Within 400 feet of the pad, flames and heat from the engines will kill you. Within 800 feet, the sound will kill you. Within 4,000 feet, the snakes and alligators might kill you, because all that low-frequency vibration really stirs them up. But I'm getting ahead of myself. Let's back it up to T-minus 10 seconds. Those sparks are hydrogen pre-burners or sparklers. They help prevent a fire or explosion by burning off any excess fuel around your vehicle. At T-minus 6.6 seconds, a loud roar, and you'll feel a big rumbling. After the main engines start, you'll feel the shuttle sway forward a little, but don't worry. It's engineered to come back to vertical before you go. That's what we call the twang. You're getting a lot of power from those main engines, but you're going to need even more to get to orbit. That's where the solid rocket boosters, or SRBs, come in. These guys were the most powerful solid fuel rocket engines ever flown. The SRBs ignite when the countdown gets to 0. And believe me, you'll know it. Once you fire the SRBs, you can't turn them off. So you're going somewhere. You better just focus on it. Now, here's how all that's going to happen to you in real time. 10 seconds. Start. 7. 'Doesn't happen, we throttle down the engines to maintain pressures we engineered the shuttle to withstand. Once you pass through max Q, we throttle the engines back up. Down, go and